Hey guys, I hope you're doing well. I just wanted to come to you today to look at shapes or quadrilaterals. Remember that has four sides, a quadrilateral. Shapes or quadrilaterals that have the same perimeter but a different area. So let's look at these four shapes here. They all look very different. They're the same sizes. However, there is something that they have in common. So we're going to go through each shape and look and see what we notice that they have in common. So on this shape here, we see that the width is 1, 2. We see that the length is 1, 2, 3, 4, 5, 6. So we know that if this side is 6, this side has to be 6 as well. Same with this side. So to determine the perimeter of this shape, remember what we do? We add all of the sides together. So 6 plus 6 plus 2 plus 2. 6 plus 6 is 12, 13, 14, 15, 16. So the perimeter is 16. Now let's look and see what the area might be. Remember, area is when we do the length times the width to figure out how many total squares take up the entire space of the quadrilateral. So I could just count the squares, but they don't always give us squares to count. So we can do our equation that we know is 6 times 2, the length times the width. So 6 times 2 is 12, and then remember we always say square units or square inches or square feet. Because they didn't give us inches, feet, or yards here, we can just say units squared or square units. Okay, so we know the perimeter of this is 16. The area, how much space is taken up inside, is 12. Let's move to this one. We see that the width is 1, and the length is 1, 2, 3, 4, 5, 6, 7. So we know what these sides are. So to figure out the perimeter, we add all the sides. 7 plus 7 plus 1 plus 1. 7 and 7 is 14, plus 1 is 15, 16. Well, that's interesting. Both of those perimeters are 16. They don't look alike, but they do have the same perimeter or distance around. Remember, it would be like if you took a string and put it all the way around and then measured that string straight out. These would be the same perimeter. Now let's see about the area. Remember, area is length times width. So we've got 7 times 1. So 7 times 1 equals 7 units squared. So we've got the same perimeter as this one, different areas. And we can tell that because there's a different number of squares inside. Let's look at this one and see if it has anything in common with these. So we see that the width is 3. The length is 1, 2, 3, 4, 5. So to figure out the perimeter, we would do 3 plus 3 plus 5 plus 5. See if I can get down here and write this equation. 3 plus 3 plus 5 plus 5. 3 plus 3 is 6, and 5 more is 11, and 5 more is 16. Just like the perimeter of these are 16, so is the perimeter of this one. Let's see if the area is the same as either one of these. We know area is the length times the width, so 5 times 3 equals 15 square units or units squared. So a different area for all three of these, but they have the same perimeters. Let's look at this one. It looks different than these, but we're seeing a pattern, so I wonder if it's going to have the same perimeter as the rest of these. So the length is 4, the width is 4. To figure out perimeter, 4 plus 4 plus 4 plus 4, we know that's 16. And then the area is length times the width. So 4 times 4 equals 16 units squared. So I see a pattern here, like I said. All of them have the same perimeter, but if you look at them, all of them have different areas. They look very different. They have a different number of squares inside, but same perimeter. So remember, your quadrilaterals can look different, but still have the same perimeter with a different area. All right, good luck on your Pearson Realize assignments, and let us know if you need any help. There are videos on Schoology that can help you. There's also videos on Epic and the Pearson website that can help you as well. See you soon. Bye.